Swifters, I hope your meal is ready for its close-up because we are about to save images to the cloud. Now, we're not only going to learn how to save images using Google's Firebase storage, we're also going to learn the critical app-building skill of saving a reference to that Firebase storage file inside of a cloud Firestore database. So this will allow our app to find the images when it needs them. Now, we'll offer a detailed explanation of the structure of saving the files to these two Google products, Cloud Firestore and Firebase storage. We'll also show code that you can use anytime you want to use just Firebase storage, but we'll also show how you can save a reference to Cloud Firestore as well. Get ready to be skilled, full stack style. Giddy up! Now let's take a look at our Firebase Console for our Snacktacular project. Up until now, we've been working with the Cloud Firestore database under this database link. We've also taken a peek inside of authentication to see the database users, but we'll save large files to another Firebase product called Firebase Storage, and that's available right here in the console under the storage link. But we need to use a different approach to saving and loading files in Firebase Storage, and there's some new code to learn as well. Now, what makes a large file? Well, think images, audio, video, anything bigger than about a megabyte. Now in this lesson, we're going to concentrate on techniques for saving and loading images, but after we're done with this lesson, you should have enough knowledge that if you wanted to work with video, say, you could check out the Firebase documentation and you should be able to figure it out on your own. Now our app will throw all of its Firebase storage files into a storage reference. Sometimes you'll hear Google refer to this as a bucket. And here's a look inside of the storage area or the bucket for my Snacktacular app. And this is after I've already coded and used the stuff I'm going to teach you in this video. We see a bunch of different folders with really weird names, like this one here, 8LJJVF, etc. But the way we're about to implement things in our Snacktacular app, that long alphanumeric folder name is the same name as the document ID for this document up here in the Firebase database, which is for the spot Shake Shack. Now, if we click to look inside of this folder, we'll see a bunch of images that I've already saved using my app. Each one of these different files inside of the folder that has the same name as Shake Shack is an image or a photo that users have taken and posted for that spot. This one here is the one for the cheeseburger. So we've got two different Firebase products. We've got Firebase Storage and we've got the Cloud Firestore database. How do we get them to work together? Like this. When we save an image to Firebase Storage, we'll pass in the spot information too, just as we did when we were saving a review. Now we'll use the spot's document ID as the folder name. Now if we don't have a folder in Firebase Storage, Firebase will automatically create one when we save an image file, which is nice. We don't have to write any extra code for creating that folder. Now inside of this folder for 8LJJ are all the images for Shake Shack. Any new Shake Shack images will be saved here in this folder, just like this cheeseburger file. Now how does our Shake Shack document know how many photos we've got, what their names are, and how to find them? Well, after we save an image to a folder in Firebase Storage, we're going to save a photo document to the Cloud Firestore database. Now this photo document is going to be saved inside of a collection called Photos. Now this collection is going to be created automatically the first time a photo document is saved for that spot. And each of these photo documents has information about the photo they're associated with. All the non-image stuff, the date the image was posted on, the image description, who posted it. So now the name of this photo document, this long alphanumeric number here, is the same name as the image that's stored in Firebase Storage. So hopefully that structure doesn't seem too complicated. Quick recap, Firebase Storage is used to store any big files, files bigger than about a megabyte. We can organize these files into file folders. We're going to create one folder for every spot. The folder for a spot is going to have the same name as that spot's document ID in the database. Each of these folders is going to have all of the photos for that spot. When we save an image file, we're also going to save a document to the photos collection of that spot. We're going to name the document in the photos collection the same name as the image. That photo document has all the non-image information related to that photo, the date, the description, who posted it. Now, those of you who are eagle-eyed might have noticed that this alphanumeric value that's the photo document name looks a little bit different than the other document IDs that we've created. How come? Well, that's because we generate the name a little bit differently when using Firebase Storage. See, previously we let Cloud Firestore name any of the documents that we had saved, but when working with images, we're actually going to save the images to Firebase Storage first, so we're not generating that name in Cloud Firestore. So how do we get a unique name? Well, in an earlier app, we learned that you can use Swift to generate a unique number. That was the UUID. We use that in our to-do list app. So that's what we're going to do here. The UUID looks a little bit different, but it's still guaranteed to be unique and never repeat. So we're going to start first by dealing with saving, but when we do get to loading, when we arrive here at the Spot Detail View controller, we currently load in all of the review documents, while we'll eventually read in all the photo documents as well. Now there's one more thing we saved in here, the photo URL. We're going to ignore this for now. Now we're doing this because when we get to loading images, I'll show you a more efficient way to deal with loading images. But rather than overload you with more information, let's just jump into saving images to Firebase storage right now and saving our related photo document in Cloud Firestore. So here are the steps for saving an image with Cloud Firestore. First, once per project, you're going to have to set up Firebase storage. Now we had to perform a similar step when we set up our Cloud Firestore database, and let's do this together right now. So open your browser and go to the Firebase Console for your Snacktacular project. Then click on the storage option on the left. Then click the Get Started button. There's a bit in here about rules, but we can even keep the default rules that show up. So when you see this, just click Next. Our location settings were already set when we created our database, so just click Done, and you'll eventually see this empty storage area. Now we'll do our image saving via a save data method that we'll have in our photo class, and it'll be declared just like the save data method in our review class. We'll pass in a spot, we'll have a completion handler. Now every time we write some code to save things using Firebase storage, we also need to create a storage object. This is the code that we'll write. There are a few more things that we're going to do that are specific to this app. So since we're working with images and the camera can take very high resolution photos, we're going to convert any images to the JPEG format, and we're going to compress them by 50%. This will save us some space. The images should load a little bit faster, and the images will still look great in our app. And this is the code that we're going to use for that conversion. Now we'll also save our images with some metadata. Now metadata is just data that describes data. So we'll add a description to every file that we upload in our app that says that that file is an image of type JPEG. And once we do this, we'll be able to click on the image in the Firebase console and immediately see that image as an image in the console without having to download it. It's a really nice thing to do when we're developing because we can just check the console, make sure our images have uploaded okay. And also in this project, since we're saving our file in Firebase storage first, we'll create a unique name for that file, and we'll use the UUID method that we learned about in the to-do list app. Now, in terms of working more generically with Firebase storage, we need to code the following steps. We need to first get a storage reference. Now, this first part of the storage reference is our project's Firebase storage area or bucket. And then after this, we have a .child for each folder or file name in the path that we're saving our document to. So, for example, in our app, we're saving to a folder that's got the same name as the Spot's document ID. So that's this first child here. And the second child is the photo's document ID property, and that's going to contain this UUID value that we create. Then we create this thing called an upload task. Now, it runs the upload in a separate thread, so it doesn't have to hold up our app if we don't want it to. And as the upload progresses, its status is going to change. So we can actually react to changes in the upload status by writing blocks of code to look for, observe, and respond to specific changes. So if we were uploading a really big file, we could actually observe the progress of the upload and show a progress bar. But our upload of photos is going to occur pretty quickly, so we won't need to do that. But the status we will observe that we hope that we see all the time is .success. Now in our app, we're going to add some extra code when we observe success, and that'll go ahead and create a photo document in Cloud Firestore for this Spot's photos collection, and that'll have all the additional information for the image that we just uploaded. The date, the description, who uploaded it, and hopefully we'll never observe this one here, but if we do observe .failure, we need to handle the error. So let's code this up. So we'll start our coding off in photo.swift. We'll make some space just before the last curly in the class. Then we'll head over to review.swift. We'll find the save data method in this class. We'll highlight the first definition line of this function, copy it, return to photo.swift, and paste it just before the last curly and add a closing curly. Now, since we need to refer to our project's Firebase database, let's create an object pointing to that. So we'll say let db equals capital Firestore dot lowercase Firestore, open and close parens. And the next line does the exact same thing, but for Firebase storage. So we'll say let storage equals capital storage dot lowercase storage, open and close parens. Then I'll comment out the different things that I'm about to do. For example, right here, I'm going to convert photo.image to a data type so that it can be saved in Firebase storage. And we do that with this guard statement. We'll say guard let photo data equals self.image.jpg. We see this method here. Code completion describes it, saying it returns a data object containing the specified image in JPEG format. So it will convert whatever's in my image, the UI image data type, into a JPEG. We'll press return to accept this. We'll pass in a compression quality of 0.5. That will compress it down to 50% its original size. It'll still look great in our phone, but it'll save some storage space, and the smaller images will load and save more quickly. Now after the parens, we'll say else, open and close curlies. Then in the curlies, we'll print an error statement with print, angry emoji, error, colon, could not convert photo.image to data, with the guard's return statement below that. Then below this, let's create that metadata so that our image shows up in the console in our browser. So I'll put in a comment that says create metadata so that we can see the image in the Firebase storage console. And we'll create a constant let upload metadata, and we'll say that that equals to capital storage metadata, open and close parens. Now the metadata are sort of like tags for our data. In this case, we're going to use a tag that tells the type of content that the data is. So we're going to say upload metadata, the constant we just created, dot content type, see that in there, equals, and then we'll pass in the string image/JPEG. That's all lowercase. JPEG is JPEG. Now our comment for this next block is create a file name if necessary. And this is the block where if we don't have a document ID, then we'll create a new file name, and we'll do that as a UUID. And to do that in code, we'll say if document ID equals empty string, open and close curlies. And inside, to create that document ID, we say document ID equals capital UUID, open and close parens, dot lowercase UUID, select this option with the string. That little chunk of code after the equal sign creates a guaranteed to be unique UUID string. Next comment, create a storage reference to upload this image file to the spots folder. And we'll do that with let storageRef, lower camel case, equals storage, that's in lowercase, dot reference. Code completion says that this initializes the root Firebase storage location, so off of this is where we build all of our file folders and eventually our file name. Press return to accept this, dot. And up top here I'll show a screenshot of the Firebase storage console so that you can see how the code that you've written relates to the storage location. Then we'll say child. For the path in between the parens, we'll say spot.documentID, that's the name of the folder. In our app, we store images only one folder deep, so the next child is going to be the file name. So to add that, we add another .child, and in between these parentheses, we'll just say document ID. That's the UUID that we just created above, and that's also the name of this file. Our storageRef, which is our path to saving the document with the document name, created. And next up, we create an upload task, and we do that with this statement, let upload task equals storageRef dot, and then put data. That's the upload task method that we're performing. You've got a few options in here. The option we want is this one with the upload data and metadata parameters and the completion handler. Now it'll take the JPEG that we just created in photo data and upload this to Cloud Firestore. Just a quick note, this not recommended warning for large files that you see is for very large files, like video that would be stored on disk rather than in memory. Don't worry, we're doing exactly what we should be doing for images. Just select that. Our upload data is going to be the photo data value that we'd created. Our storage metadata parameter is going to be the upload metadata value we created. Then double click on the completion handler. That gives us the trailing closure format. We'll call the storage metadata, and the error parameter error. Now the only code that we'll write in the handler for creating the upload task will check for an error and print an error message if we get one. So we'll say if let error equals error, open and close curlies, then print, and the message will be error : upload for ref string interp, and that'll be upload metadata failed period string interp. And there we'll put error.localizedDescription, and I'll add angry emoji to the front. Next up, we'll add our two upload task observers. So the first is our success observer, and to do this, we say upload task dot observe. We'll highlight this option that has the status parameter and a completion handler, and it passes back a string. Now, if you look at code completion, you'll see that there are lots of different statuses that you can observe, including resume, pause, progress, success, and failure. So let's press return to accept the highlighted option. And for our status, we'll type in dot, and again, we see all the different available status options. We want dot success. Double click on the completion handler. And for this storage snapshot task value, why don't we just call this snapshot in lowercase. Inside the handler, we'll print a message that says, upload to Firebase storage was successful. Now we'll write some more code in here in just a second, but I'll put in a little to-do reminder. For our app, we'll also want to save a photos document to spot.documentID. Now let's do the upload task for failure. Hopefully you'll never see that. That's the same statement as the one we have above. So we say upload task dot observe, but inside we'll pass in dot failure. Double click on the completion handler. We'll once again call our storage task snapshot just snapshot. And inside the handler, first we'll check to see if we got an error. If let error equals snapshot.error, open and close curlies, and then we'll print the error message. Print error : upload task for file string interp self.documentID failed, in spot string interp spot.documentID, with error string interp error.localizedDescription. Also vitally important, don't forget this or else the function will never run its own completion handler. We need to add our completion statement. So inside the curlies, if we observe success, we'll say completion with true in parentheses, and inside the curlies, if we observe false, we'll say completion with false in parentheses. So we've created a task. We observe two potential statuses, success and failure. This is more or less the typical setup whenever you want to save an image to Cloud Firestore, but as we mentioned in our app, we've got a little bit more to do, so let's go up here and fill in after our to-do comment. So now that we're done with the Firebase storage portion of the save, we need to handle the Cloud Firestore database portion. So this is going to be where we save our photo document to the photos collection for this spot. And hey, when you think about this, we've already saved a review document to a reviews collection. I wonder if there's some code in the review class that we've already written that we can easily modify for photo? There is indeed. Let's open up the review.swift file, head to its save data method. Now we're going to need these two lines up top, the one that creates a database object and this other one that calls self.dictionary to prepare the data to be saved to the Cloud Firestore database. So let's highlight these, copy them, head back to photo.swift, and paste them into our success observer. Now let's continue the code raid. We'll head back to review.swift, and if we look at the code, this first part of the if statement is how we save a review that doesn't have a document ID. See this if statement here? But in our photo example, we've got a document ID. We're going to be using the UUID value that we've already created. So we're never going to need this call to .addDocument. That's the method that creates a custom document ID. We never want that. So we only need the else clause in the code to save the data to the database. So let's highlight all of this code that's inside of the else block. Make sure you're highlighting the right block. So from letRef equals through to the curly after completion equals true. Copy it, return to photo.swift, and paste that in after our letData2Save line. Now let's see, the statement that we just pasted in already has completion flags that will flag if the statement works or doesn't work. So we can delete this extra completion flag that we originally wrote down here. We don't need that anymore. And also, just as an aside, we don't need to specify the data to save as being a dictionary type string any. That's already defined in the dictionary computed property itself. Leaving the type in here is actually kind of nice. It sort of functions like a comment to remind the developer that data to save is in fact a dictionary. But just to show you that I can delete this without any side effects, I'll do that now. Feel free to leave yours in. Now let's check out the rest of the block of code we pasted in, and it looks like the only thing we need to change is this reference to the collection reviews. Remember, we're going to want to save this now to the collection called photos, all lowercase, but that's it. Now I am going to change the to-do up here because we still have to return to do a little bit more work. I'm going to put in update with photo URL for smoother image loading. That's in the next video. Now as I look at my code, I'm noticing one other issue here. It's not going to harm our executing code, but it's a redundancy. We've declared a database object named DB twice. Once is plenty. So you see how this one up top is being flagged in yellow, that it was never used. So we can delete either of these, but since declaring the database object is very similar to declaring the storage object, and we do that up top, I'm just going to go down here and delete this one that's in our observe success block. So good, everything is done in photo.swift. Now let's head over to photo view controller, and we'll call our new save data method when our save button is pressed. So in Photo View Controller, let's jump bar down to Save Button Pressed, and right now we're just leaving the View Controller. That's not enough. So let's head over to Review Table View Controller, and let's see what we do when we press the Save button to save a review. So we'll hop down to Save Button Pressed in Review Table View Controller, and this block looks like it provides a great template for what we need to do. Let's highlight everything inside of the Save Button Pressed function in Review Table View Controller. Don't highlight that final curly. Always make sure that you've selected the right code block. So copy that, then we'll head back to Photo View Controller. I'll paste this whole block in right at the start of this function, and instead of calling review.saveData like our template does down below, we want to call photo.saveData. Code completion acknowledges its existence. Nice. So select that option. For spot, we'll pass in lowercase spot. Let's double click on the completion handler. Our bool will be success. Then we can copy this whole if-else block that we just copied from a Review Table View Controller, and we'll paste it into our completion handler underneath photo.saveData, and now we can delete all the code we just copied over as a guide, but let's change the error message so that it refers to Photo View Controller instead of the first review, and Photo instead of the second review. Now we're also getting an unresolved identifier error for update from user interface, and that's because we've never written this function update from user interface. So let's go ahead and write this right underneath update user interface. So we'll say func update from user interface, open and close parens, open and close curlies. Now there are only two user interface elements that we need to get data from before we save. So down here we'll say photo.description equals, and that's description text view.text exclamation point. And the second one is the image, photo.image equals photoimageview.image exclamation point. Look back at our save button pressed. No more errors. Let me set my scheme and then let's go ahead and build and run and see what we got. No errors. Hammer time. I'm going to open the Snacktacular console in 2 tabs so you can see what happens as we save an image. In 1 tab, I'll have the database console, and I'll select the record for the spot where I'm about to add photos. For me, it'll be Island Creek Oyster House. And in the other tab, I'll show the Snacktacular storage console. It's currently empty. And now let's pull up our glorious app. I'll select Island Creek. I'll click the photo button. I'll choose Photo Library. Select all photos. Click that yummy lobster roll. I want some of those scrumptious sea bugs. And here it is in our photo view controller. I will write lobster roll as the description. Pro tip, even though I don't speak with a Boston accent, most Bostonians don't like it when you use a fake accent when speaking with them. I'm not offended, though. We can still be friends. Now, let's notice I am saving this while logged in as prof.gallagher. I'm going to click on Save. Now, I don't see anything in the app. We haven't updated it to load in the image yet. But over in the console, look at how the Island Creek document doesn't yet have a photos collection. But if I click on the address bar and press return to refresh the page, ho-ho! We can see that the photos collection now exists. Click that. We've got 1 photo document. It starts with D2058. Now also notice the document ID of the spot document that we're in, Island Creek, is P2MHL. Now let's click on the photo document we just created, and we can see the document's deets. The date posted in incomprehensible time interval format, the lobster roll description, verification that it was indeed posted by prof.gallagher. Cool. Now, let's check the tab that shows the storage console. Nothing. But if we refresh, here it comes, and miraculous! Will you look at that? We've got a folder named P2MHL, the same document ID for Island Creek. Let's click that folder. And inside we've got an image file. This one starts with D2058. That's the same name as the document ID for the photo document we just saw in the photos collection in the Island Creek document. Let's click this. And sweet snackin' storage, will you look at that? Our metadata lets us see our luxurious lobster roll. Dang, that looks tasty. Now let's verify things are working for the other users. Let's head back to the app. I'm gonna sign out. Then I'm gonna sign in as a different user this time. John.Gallagher instead of prof.Gallagher. Click inside Island Creek. Again, no photo show, but not surprising. We haven't written a load function yet. That's for the next video. But click the photo button. Select Photo Library. All photos. This time I'm going to click on that plate full of clams, and I will describe this as bivalves, baby. Save that glorious pic. Then click that photo button again once more for good measure. Select Photo Library. All photos. Let's grab the salmon image. I will describe this as slammin' salmon. Save that fabulous fish. Then let's refresh Firebase storage. Gadzooks, my friends, will you look at that? There are 3 images saved in this folder. Click them up. Salmon, clams, lobster. Dang, I am hungry. Let's look at the database tab. Yes, we can see now that there are 3 documents in the photos collection for the Island Creek spot. Click the second one, Slammin' Salmon, posted by John.Gallagher. How about that top one? Bivalves, baby, also by JG. Nice work. Swifter, you are saving images to the cloud. Another full stack skill in your superhero utility belt of developer awesomeness. Next video, we'll learn how to load these bad boys into the collection view. Keep at it and stay swifty, my friends.